Ladies and gentlemen, welcome to the first UTHM lecture series for 2021. We will start this event with the recitation of dua led by Ustaz Muhammad Lutfi bin Solihan. Please welcome.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil mursalin Sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Allahumma salli ala Sayyidina Muhammadin al-Fatihi lima ulika wal khatimi lima sabaqa wal nasir al-haqi bil haq wal hadi ila siratin mustaqim wa ala alihi wa sahbihi haqqa qadrihi wa miqdaril azim. Ya Allah, ya Tuhan kami, di hari yang mulia ini kami mohon kehadrat-Mu, berikanlah kekuatan, taufik dan hidayah kepada diri kami, supaya kami dapat memperbaiki diri kami, dan tambahkan kepada kami, ya Allah, ilmu, iman dan amal. Kuatkanlah tekad dan semangat kami untuk berkhidmat kepada universiti ini dengan lebih cekap serta cemerlang. Ya Allah, ya Tuhan kami, dengan keluasan ilmu-Mu, kami mohon agar Engkau berkati dan rahmatilah Majlis Syarahan Perdana Siri pertama 2021 yang akan disampaikan oleh Yang Berbahagia Profesor Dr. Talib bin Bon yang akan diadakan pada pagi ini. Ya Allah, Tuhan kami, kurniakanlah kepada kami ilmu-Mu, sinilah di hati-hati kami dengan cahaya dan hidayah-Mu. Semoga dengannya kami mudah menerima dan menghayati serta mengamalkannya. Ya Allah, ya Rahman, ya Rahim, ya Rabbal Alamin. Keperbaikilah akhlak kami. Kau hiasilah diri kami dengan akhlak-akhlak yang baik dan terpuji. Hindarlah diri kami dari sifat-sifat keji. Hindarlah kami dari sifat lalai yang merugikan. Dan bimbinglah kami ke arah jalan kebenaran. Ya Allah, ya Hayyu, ya Qayyum, ya Dzal Jalali wal Ikram. Kau terangilah hati kami dengan cahaya petunjuk-Mu. Bukanlah kepada kami pintu hikmah-hikmah-Mu, dan limpahkan kepada kami daripada hazanah-hazanah rahmat-Mu. Inilah diri kami dari sebarang bentuk bala bencana, wabak dan penyakit yang berjangkit. Ya Allah, kurniakan kepada kami kesihatan yang sempurna, dan muliakanlah kepada kami dengan ketakwaan, serta donorlah kami dalam meniti redha-Mu. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Walhamdulillahi rabbil alamin. Taqabbalallahu minna wa minkum.
Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and a very good day to all participants of the first UTHM lecture series 2021. We are honored to welcome the distinguished guest, Professor Dr. Teknologis Dr. Wahid bin Razali, Vice Chancellor of University Tun Hussein on Malaysia, Professor Teknologis Dr. Azmi bin Khamis, Deputy Vice-Chancellor, Academic and International UTHM, Professor Dr. Muhammad Shahir Samsir bin Omar, Deputy Vice-Chancellor, Research and Innovation UTHM, Associate Professor, Surveyor Teknologis Dr. Haji Lokman Hakim bin Ismail, Deputy Vice-Chancellor, Student Affairs and Alumni, Associate Professor, Teknologis Dr. Muhammad Kamarul Zaki bin Mustafa, Provost UTHM Pagoh Campus, Professor Dr. Wan Fauzia binti Wan Yusof, Dean of Fakulti of Teknologi, Management and Business UTHM, and also the Chairman of UTHM Council of Professors. The keynote speaker, Professor Dr. Muhammad Talib bin Bon, Fakulti of Teknologi, Management and Business UTHM, all UTHM senior officers, lecturers, students, and everyone attending this event live and online at the comfort of your office or home. Ladies and gentlemen, let me enlighten you on this first UTHM lecture series for 2021. The event is organized by Council of Professors UTHM and co-organized by the Chancellor Office in collaboration with Faculty of Technology, Management and Business UTHM. This event will provide a great opportunity for sharing the knowledge to all of us and also hope to inspire us to do better in the future. Without further ado, we would like to invite Professor Dr. Wan Fauzia binti Wan Yusof, Chairman of UTHM Council of Professors, to introduce our keynote speaker for today's lecture series. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh and good morning. The Honorable Professor Datuk Teknologi Dr. Wahid bin Razali, Vice Chancellor of University Tun Hussein on Malaysia, Senior Officers, Professors, Head of Officers, ladies and gentlemen. First and foremost, I would like to thank the committee for giving me the opportunity to participate in UTHM Premier Lecture Program Series 1 2021. It is hoped that this program can benefit everyone, especially from the new information and knowledge that will be delivered by the speaker. The program will also be able to generate new ideas based on the experiences of the speaker that will be shared to us today. Ladies and gentlemen, to begin with, allow me to introduce our speaker today, Professor Dr. Talib bin Bon. Professor Dr. Talib bin Bon was born in Kuala Selangor on 4th of April 1965. He is married to his beloved wife Puan Mazni Sakinah Yaakob in 1989 and blessed with 2 children and 1 grandchildren. Ladies and gentlemen, Professor Dr. Talib bin Bon obtained his diploma in mechanical engineering from the University Teknologi Malaysia in year 1986. In 1991, he then completed his bachelor degree in mechanical engineering at the same university. In 1998, he obtained Masters in Business Administration, majoring in Quality Management from Universiti Kebangsaan Malaysia. In 2008, Professor Dr. Talib bin Bon was awarded a PhD in Computer Science from the Université de La Rochelle, France. His thesis focusing on process quality improvement on Backline molding manufacturing. In addition, he was also awarded a postgraduate certificate in mechatronics and robotics from Carlisle, United Kingdom in 1997. Ladies and gentlemen, Dr. Talib bin Bon is a professor of the Department of Production and Operations Management, Fakulti of Teknologi Management and Business, University Tun Hussein on Malaysia. He has over 33 years experience in teaching at higher education institutions. Much of his teaching experience involved teaching mechanical engineering students. In the early stage of his career as academician, he was the lecturer at Malaysian Polytechnics. In 1999, he joined Institute Teknologi Tun Hussein on, or ITO, University Teknologi Malaysia. In year 2000, when the Malaysian government awarded a university college status to ITO, become Quito, then become UTHM in year 2007, he remains as an academic staff of UTHM until today. Being one of the senior staff of the university, Professor Dr. Talib bin Bon has been appointed holding few management positions. Since 1st September 2016, to present. He is the Director of Teaching Factory, UTHM. Prior to that, he also served as Deputy Dean, Research and Development at the Fakulti of Technology, Management and Business, UTHM from 2008 to December 2011. He was appointed as Head of Program Bachelor of Technology Management in Furniture Design and Manufacturing with honors from 2014 to 2017. Ladies and gentlemen, Professor Dr. Abdul Talib bin Bon has multidisciplinary research interests that cover forecasting, simulation and modeling, optimization, industrial engineering, quality management and operation. To date, he has completed 25 research grant projects as project leader, including forecasting applications in industry. His current research project is looking into the development of process quality improvement in the manufacturing industry. He has supervised more than 77 undergraduate and postgraduate research projects. He has served as a reviewer for several engineering and computer science management conferences and journals as part of his expertise sharing initiative. He has published more than 381 Scopus international proceedings and international journals and 8 books. He is also the president of the Industrial Engineering Operation Management Association, Malaysian chapter, a member of the Global Council and Industrial Engineering and Operation Management Association, a member of the Malaysian Society of Management Science and Operation Research, a member of the International Association of Engineering, a member of the Institute of Industrial Engineers, USA, and a member of the International Institute of Forecasters. Ladies and gentlemen, with all due respect, I welcome the Honorable Professor Dr. Abdul Talib bin Bon to deliver his lecture entitled Production Forecasting, Technique and Applications.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. The Honorable Professor Dato' Teknologi Dr. Wahid bin Razali, Vice Chancellor of University Pengurusan on Malaysia, Senior Officers, Professors, Head of Office, ladies and gentlemen, and also from the industry and students. Okay, today I would like to present my topic about the production forecasting technique and applications. Actually, this is my research compilation from my research since 2001 until now. So this I would like to present about the my research about the demand forecasting in inventory management, overall equipment effectiveness forecasting using Markov Chains, forecasting using Arima in backline molding contours, forecasting model selection in Six Sigma concept, and application of artificial neural network to forecast product defects. Actually, this my research with the industry. For example, we did research for overall equipment effectiveness forecasting with the machine manufacturers industry in Penang, and for the forecasting using Arima in backline molding contours, we did the research with the automotive parts manufacturers in Nilai, and forecasting model selection in Six Sigma concept is a collaboration research with the plastic manufacturers in Shah Alam, and the last one is the application of artificial neural network to forecast product defects. This one is a collaboration research with the furniture industry in Muar. Okay, so we continue for this session with the chapter 1, Introduction to Production Forecasting. Okay, back to the history of the forecasting. Actually, this forecasting is not the new techniques or the new application in the industry, but it has the have the history and then have the evolution of the forecasting since the ancient classicals, okay, and then that time these are more for the intuition forecasting, and then the next evolution is apply the mathematics to nature, and then inventing statistics. This one is when the application since the 18 to 20 years of centuries. And then from the evolution, this after World War II, this time is developing the future studies on the forecasting. And then the forecasting have the evolutions late the 20th of century, which is that time we did more to the predictive analytics, and then now 21st century more to the structured quantified forecasts. Type of the forecasting. Okay, actually we can divide by 4 type of the forecasts. Okay, the first is economic forecast. Economic forecast is more to address the business cycle, for example, the inflation rate, the money supply. And then for the second types is what we call the technological forecast. Technological forecast is more to the predict technological change. Okay, which is this one is more to the predict the new product sales. And then the third type is what we this one is we call the demand forecast. Demand forecast is more to predict the existing product sales. And then for this number 4 type of the forecast is production forecast. Production forecast is more to the predict on product demands, the defects, product failure, and maintenance. Okay, so for the qualitative techniques in forecasting, because in forecasting we can divide by 2, this quantitative technique and qualitative techniques. For the qualitative technique, more to the grassroots. Okay, grassroots is to make the prediction by add the data step by step from bottom, and then when the we go to the look about the market research. Okay, this one is still the qualitative techniques we use. This one is a method of the collecting data, mainly the survey and interview. And then for the next techniques, panel consensus. This one is more to the opinion to the from the 2 person are better than 1 person in extrapolated to the thought that individual board of different posts can get more unwavering the quality in expectation from a smaller bunch. And then another techniques, yeah, this one is a historical analogy. Historical analogy is a method usually utilized to predict demand of products or service under the condition that have no past request data. And then the quite famous technique, what we call the Delphi methods. Delphi method is the fact or idea from the higher level of person can be heavier than the person in the lower level. In the forecast, this what forecasting, this we use the historical data, and then when we use the historical data, so that means we must using the time series method. In the time series method is a quantity techniques. Here we have the 4 techniques or 4 the methods we can use. This one is what we call the naive methods. Okay, naive methods is use the most recent rate value using time series or the forecast for the next coming period. And then the second method, moving average. Moving average we can divide by 2 methods. This is a simple moving average methods and weightage moving average. And then the third methods in the time series methods is exponential smoothing. Exponential smoothing, this is a method we can make the prediction of the past data with the weight is reduced exponentially with time. Okay, which is we can put the exponential method based on the weight value. And then the last one is a trend projection. Trend projection is the classic strategy of determining the deals that's concerned to the development of variables through times. This one is another methods in forecasting. This one is a common method, what we call the regression analysis. The regression analysis is a powerful statistical method that helps you examine the relationship between the 2 or more attractive variables. Although there are many types of regression analysis at their core that all study the influence of one or more independent variables on dependent variables. And then from this regression analysis, we must, this very important to understand the following terms. Okay, the following terms is have the 2 dependent variables. This most calculated, the attempting to get is all the 4C, and then the second is a dependent variable. This is affected that hypothesis have an effect on your dependent variables. In the production forecasting, what the principle of the production forecasting is any point in time there is only one best estimate forecast for a project that reflects the current understanding of subsurface uncertainty and best development and common commercial assumption. This forecast should always be accompanied by an uncertainty range. The forecast uncertainty range should always have remaining reserve or objective function. So this one is what the principle of forecasting, production forecasting. And then what the definition for this production forecasting is the forecast definition will enable a lean forecasting process by allowing for a single consistent forecast that will be the basis for the resource estimation, decision making, and business planning. And then for the forecasting, we have the 3 length of the forecast. The first is a long terms, medium terms, and short terms. And then for this, this one is based on the requirement for this the research. If the research is a need the short term, we can use the short term methods. So in the forecasting, the very important the accuracy of the forecast value, and then what the smallest numbers of the errors. So that means we can identify the research is a need the long term, medium term, or short term. And then the production forecasting approach. This one is likely to differ depending on the specific objective of the particular forecast, the customer or the forecast and their particular needs, and then the phase or stage of the field life. And then this one is what the production forecasting objective, because the forecasting objective we need the three-step process, identify what the decision will be made using the information from the forecast, identify what the uncertainties matters for this decision, and how we can design of the forecast. And then summary for this chapter. Chapter 1 is the approach for the each production forecast will vary depending on these basic parameters. It will always be important to ensure that the purpose is defined correctly and that the definition as well as the limitation and uncertainty are clearly communicated to the relevant customer. And then we go to the next chapter. Okay, this chapter is discuss on the demand forecasting in inventory management. What the demand forecasting? Demand forecasting is include the prediction, projection, or estimation of expected demand of the products over a specified future time periods. The demand for product frequently change in the marketplace due to the seasonality factors, trend factors. Several past studies or some inventory management textbooks have shown that the accuracy of the demand forecast significantly affects safety stock and inventory levels, inventory holding costs, and customer service. Demand forecasting is inventory control has become an important component in supply chain management. One of the critical success factors in inventory management is accurate demand forecasting. Many chapters has used different approaches to generate forecast or product demand for inventory control purpose. For the individual forecasting techniques, 4 statistical product forecasting technique has been chosen as the individual forecasting technique. The techniques include in the chapter were moving average method, hot winter exponential smoothing forecasting methods, auto-regressive integrated moving average or Arima method, and the last one is a simple linear regression methods. We go to the first method, moving average method. Moving average method for this research is 9 models of moving average has been tested in the chapter. The variables for the moving average methods is the number of period or T symbol. Hence, in this chapter, the number of period is from 1 to 9. Among the 9 models, the best model is the 7-month moving average model. The total rank value for this model is 4, which accumulated every 1 point from 4 forecast measurement. We can look at for this tables 2.1 forecast measurement result for different period of moving average methods. This one is we using the 4 error analysis: mean absolute error, mean absolute percentage error, mean squared error, and root mean squared error. And then from that analysis for the error, we can make the ranking from the first ranking to the last ranking. What for the first ranking is the best moving average, and then the last is the worst. And then for this analysis, we found the best moving average is for the T period is 7, and then the total rank is 4. And then the worst total rank is for the moving average for the period 1. So this one is what we found for this period based on the moving average methods. From the table 2.1, we can show by the graph, okay, the actual graph, the actual line, and then the forecast line. From this table 2.1, there are differences between the best model and the model. In the term of the ME, mean absolute error, the best model, which is a 7 months moving average model, had reduced 8.29 as compared to the worst model, which is the 1 month moving average model. And then from the figure 2.1, show the forecast value using the 7-month moving average model and actual value of the sample CTB11. From the figure 2.1, there are a few points that had great differences between the forecast and the actual value. The first point for this research is from the November 2006, the actual value is 167, while the forecast is 70, and thus the forecast error is 97. And then we go to the next method, hot winter exponential smoothing forecasting methods. This one is the second individual forecast technique in the hot winter exponential smoothing forecast methods. In this study, the value of alpha and beta being tested from the 0.0 until 1.0. Based on the difference value of the alpha and beta, a total of 121 models had been tested with the gamma remain constant, which is 0.0. From the MAA, MAP, MSC, and RMC SE, value for the 121 models had been ranked from the lower values to highest value, and the total rank value had been summed. The top 5 models with the lowest total rank values and bottom 5 with the highest total rank values is a summary in the table 2.2. From this table 2.2, we can make the ranking from the top ranking to the worst ranking. This what we found that from this hot winter exponential smoothing model, we found the best ranking is when the alpha is 0.1 and beta is 0.1. And then the worst ranking when the alpha 0 and beta 0. From the figure 2.2, which was shown the actual value and the forecast value using the hot winter exponential smoothing forecasting method with the alpha 0.1, beta 0.1, and gamma 0.0 for CTB11. So this one is how we can show the graph, and then we can compare the actual and then the forecast value. And then the third one is the individual forecasting technique, is when we using the auto-regressive integrated moving average, or the Arima methods, which is the 45 different types of the Arima model have been tested. The top 8 model with lowest total rank value and bottom 5 models with highest total rank value are shown in table 2.3. Among the 45 models, the Arima model with the lowest total rank value is the model 1, 0, and 3, which the total sum is 9. So based on this table, we can see the forecast measurement result for the top 8 and bottom 5 Arima models, which is the PDQ. The best for the total, the top rank is for the P is equal is 1, D 0, and Q is 3. And then the worst is P 4, D 2, and Q 0. This one is we can shown to by this graph about this result when we using the Arima methods with the P1, D0, and Q3. And then the fourth individual forecasting technique are the simple linear regression method. In this study, we use the ability of the forecast software to determine the optimum linear regression models, and then the model can be written as y equals 60.01 plus 0.51x, where y is the stock out volume and x is the time. The forecast measurement result for this model are MAE is 30.59, MAP is 32.07%, MSC is 1,404.91, and RMSE value is 37.48. This one we can show to figure 2.4. Okay, this one is how from the when we using the linear regression methods, we can find compare the actual line value and then the forecast value. And then for the quite interesting in this this chapter is a combination forecasting techniques. This one in total, they are all together 11 forecast combination models for each combining methods in this chapter. There were 4 single forecasting methods involved in the combinations. And then from 4 single forecasting methods, total 11 model has been generated. For each of the combination methods, where 6 of the models involve the 2 methods, 4 of the model involve the 3 methods, and 1 model is the combination of all 4 methods. And then from that we can use the equal weight combination forecast methods. This one is the techniques is the equal weight combination forecast method, the forecast measurement result which consists of 11 combination model using the method is shown in the table 2.4. This one is how we can look the forecast measurement result for the equal weight combination methods. We can look the total, the top rank, the best rank is when the equal weight combination forecast is Arima and linear regressions. And then the worst is a moving average and linear regression. From that, we can show to you the graph about the equal weight combination forecasting methods. When we using the linear regression method with y equals 60.01 plus 0.51x. And then another method is a multi-regression combination forecasting method. The second combination forecasting method is the multi-regression combination forecasting methods. This one is when the weight for the method is determined by using the regression methods, and the weight for each individual forecasting method is a difference. Okay. This one we can show in this table 2.4, which is the top rank is when the multi-regression combination forecast, when we using the moving average, the hot winter, the linear regression, and we plus with the Arima. This one is all for the technique we combine in one analysis. And then moving average and hot winters is the worst ranking compared to the others. This one is what I can show about the graph when we using the multi-regression combination methods. And then we can look how the individual forecasting technique versus combination forecasting technique. So overall, it seems clear that combination forecasting method outperform all the individual forecasting methods. This one we can look the equal weight is much better compared to the moving average and then others individual methods. And then the summary is overall the best method among the 6 methods is the equal weight combination forecasting methods. And then we go to the chapter number 3 is overall equipment effectiveness of OEE forecasting using Markov Chains. Total productive maintenance can be defined in terms of the overall equipment effectiveness or EE, which is the term can be considered a combination of the operation maintenance, equipment management, and available resources. This one is we quote from the Chan 2005. The Markov process is useful for studying the evolution of the system over multiple and repeated trial in successive time periods. Since the system state at a particular time is unknown, hence making people interested in knowing the probability that a particular state exists. When we using the Markov Chain model, OEEs can be predicted over a certain period so that precaution and initiative can be taken to maintain if a good state is shown or to improve if an unfavorable state is shown. From this forecasting technique for this OEE, this tracking OEE provides a relative monitor of equipment productivity and the impact of the improvement efforts. Understanding of efficiency losses drive the improvement efforts. This one I quote from the Delorio and Pomaski in 2003. And then the OEE is a TPM metric for the measurement equipment effectiveness or productivity. And then from here we can calculating the OEE is used. However, most are consistent in identifying three major elements of OEE. First is availability, second is performance, and third is quality. Back to the Markov chain. What the Markov chains? This one is a Markov process is useful for studying the evolution of system over multiple and repeated trial in successive time periods. And then Markov chain is a methodology can be used to determine the future probabilities or state of nature and the long-term steady states. And then we go to the TPM. TPM is the methodology and philosophy of strategic equipment management focused on the goal of building product quality by maximizing the equipment effectiveness. It embraces the concept of the continuous improvement and total participating by all employees and by all departments. This one is from the Society of Manufacturing Engineers, 1995. And then how about the Markov chain in TPM? This exists a number of quantitative models that describe the impact of preventive maintenance on the life cycle cost of equipment. Markov state models are frequently used for the modeling deterioration process in which 3 to 4 iteration stage and normally introduced. This one is a quote by Chen and Trivedi, 2005. Based on the previous case study, Wang and Wang, 2004, have used the Markov chain decision analysis to predict maintenance time cycle so that optimum time to perform maintenance can be obtained in order to prevent overperformance maintenance costs. They also use the Markov chains to evaluate the maintenance policy, obtain maintenance performance from the structure of optimal policy, and also to help the determining the effective and efficient schedule and plans. This one is the methodology when we using the OEE. Yeah, this one is the formulas I can show as below. Okay, how to calculate the OEE, the availability, operating time, plan production time, performance efficiency, ID cycle times, quantity rate, and good pieces. From this analysis, I can share about the how about forecasting analysis when we using OEE in the when we using Markov chain in OEE. Based on the forecast for the single mounted technology one, this one is a line 1. This one is a research with the automotive the machinery manufacturers in Penang. So this one is all the data from that company. So we made the forecast for the SMT1 and until the SMT4. Okay, first we can go to the look about the SMT1. SMT1 is a probability of the state in current period to stay at own stage in next period for SMT1. Okay, based on this result, we can find the 76%, the probability state number 1 is in the current this still in the state number 1, and then the probability can shift to the state number 2 only 24%. Okay, and then there's a single mounted technology number 2. This one is when we look above this table, we can find the 93.70% is a probability can the state 1 still in the state 1, but only the 6.30% most the probability can move to the state 2. And then the SMD3, this one is 100% the probability will still in the state 1. So this maybe need a long time to move to state 2. And then the last one for the SMT4 is the 77.80%. The state 1 is a probability will be stick in the state 1, and just only the 22.2% probability can go to the state number 2. Okay, what the summary for this analysis? Markov chain is used to forecast the future state of OEE, so that trend of OEE to be at which state either good or bad one can be known. It has suggested that in future work, Markov chain can be used in forecasting state of elements that consist OEE, such as availability, performance, and quality. Okay, we can go to the next chapter, chapter 4, forecasting using Arima in backline molding contour. This one is a project with the automotive part manufacturers in Negeri Sembilan, all the data from that industry. And then for this analysis, we study about how we can make the forecasting based on the backline contour, the backline contour after we did the experiment and then produce from the production from that. Using that time, we used the extruder machines. One of the most consistent is a successful time series forecasting method that we'll describe, okay, in this study was the box-Jenkins methods. And then from this box-Jenkins method have a logical and organized procedure for model development when we using the ACF, the autocorrelation function, and then PACF, the partial autocorrelation function. In the manufacturing industry, there is an ever-growing demand for increased machining accuracy. Because for this study, we trying to find the very accurate analysis for make sure that backline molding we can avoid from defects situations. And then to achieve a better machine performance, forecasting and compositions, control scheme needs to be adopted and consider the process variation and other stochastic effects and use forecasting control rather than simple feedback composition. From this research, we did the experimental data collected from a backline molding process, okay, and then they are simulated by the application of the Arima. Arima is an auto-regressive moving average, and we are going to identify the formulate and estimate some suitable Arima model. From the box-Jenkins model, this approach to the modeling to time series is summarized and consists of the three phases. First is identification, estimation, and the last one is testing and application. The box-Jenkins method have a logical and organized procedure for the model development using autocorrelation function and partial autocorrelation function. And then from this, the stationary assumption implies that the probability distribution for this the series is the same for any instant. For a stationary time series, when the current value of the process is expressed as a finite, the linear aggregate of the previous values of the process and a shock where the A alpha t, the purely random process with the zero mean and variance sigma squared. This we can make the formula or the equation for the moving average based on the equation number 1 and equation number 2. In the manufacturing automotive molding, especially the backline molding that's border that the interface between a car door panels and the bottom outside edge of the door windows, it has become aesthetically fashionable to provide a strip of stiff, decorative or ornamental plastic material on the outer or inner side of the channel shape. Molding is in the combination with the coil look of the and exposed portion of the core material. This one is the cross section backline molding. Okay, when we can look the coil inside the rubber. Okay, and then this one is have the contour A, B, C, and D. And then from this analysis, we're using the univariate data analysis. This one is when we using the Bott-Jenkins model, which stationary univariate Bott-Jenkins or Arima models produce the optimal minimum mean square error forecast that revert quite quickly to the mean of the process, which are therefore only intended for short run forecast. This one is based on the code by the Dittman 2003. And then from this table, we can look at table 4.1. This is a standard acceptance dimension on backline molding cross-section contours. This one have the 5, 2, 3, and 4, 5. This one is the number of the contours. And then the direction of the contours is either is a positive or and have the negative. This one is a value, and then from that we can calculate for the resultant from the each numbers of the contours. Okay, from that we can make the analysis for the error estimate for the contours. Okay, this one is when we using the Arima, the model is a 311. Arima 1.11, Arima 111, and Arima 111. The standard error estimate we can get, the lowest is Arima 111 is 0.18638. This one is a standard error for this estimation for this contour. And then from that, for the Arima forecasting, for the forecast performance, we can show when we using the MIC, RMIC, MAP, and ME. And then from that, we can illustrate from shown by this graph. This one is Arima forecasting models ACF for the autocorrelation functions. And then we can look at about contour number 2, 3, 4, and 5. And then we can look at about Arima forecasting model, PACF. Okay, from the contour number 2 to contour number 5. And then this one is what the Arima forecasting actual forecast. Okay, this one is we can show the 12-week forecast for the contour 2, 3, 4, and 5. The actual data shown are from that mid-January 2006 to mid-February 2007. And then forecast plus and minus 1 standard error are displayed with 95% prediction interval forecast of actual contours average for a year. This one we can look at this based on the Arima models. Okay, for the from the contour number 2 to contour number 5. Okay, what I can summarize from this analysis. First, we can make the conclusion. The first conclusion is the forecast dimension of the cross-section backline modeling for best Arima model for the four contours are toward in mean range compare the actual values. The forecast values more stable and consistent condition. And then based on the conclusion number 2, the SAS program, because the analysis using the SAS program has been applied to time series data from the real data from the manufacturer and shown very good result. This program will be useful, which the model can be used by researchers for forecasting or of a cross-section on backline modeling manufacturing. We go to the chapter number 5. Okay, chapter number 5, I will share about the forecasting model selection in Six Sigma concept. This one is we found the data from the plastic manufacturers in Shah Alam, and then this quite interesting finding from this research. I think we know about the Six Sigma. Six Sigma is a quality management strategy presented by Bill Smith at Motorola in 1986. It is an approach that resulted in a change to the organization by combining the elements of the total quality management, re-engineering costs, and then employee involvement. And then for the forecasting model, for this case, is a few models of quality control, but the problem lies in choosing the applicable forecasting model to analyze the data. Forecasting objective to identify the most suitable type of the forecasting model to be used in the quality control process. Make a comparison between the methods adhered in the types of the forecasting model. Choose the average percentage of the error has the lowest value of the defects so that the type of the forecasting model can be selected and analyzed. This one is our forecasting methodology we use, which is we make the comparison between the methods in terms of the arcane information criterion, the Bayesian information criterion, the mean absolute percentage error, mean absolute error, mean square error, root mean square error, and the last one is a mean absolute deviation. And then from our data analysis, okay, from this research, we found that figure 5.1 and table 5.1 is below is the data provided from the production company used for the analysis. So this one we can look what the upper control limit and lower control limit and what the means value for this when we using the P chart control chart. Okay, look at about the table 5.1. Okay, the quantity, inspiration, and reject product examined in each week. So we check and then we analyze it, and then from the first week to the week 17, and then we can find our quantity inspection and then what the numbers of the rejected. And then this one is a potential of the effect in each week received. This one is from the week 1 and to week 17, and then we can look about how the percentage of the rejection. Okay, and then from that we can look the difference of the week 1 and until the week 17 based on the histogram diagram here. And then we go to the moving average model. Refer to the table 5.3. The most recent moving average value provide a forecast for the next period with a numbers of methods that study the percentage of error that will cause the loss of a company. And then in this table, we can find that the lowest percentage of the errors are moving average 7 with the percentage of the 39.04% MAP. Okay, this one is we can look at the error for the next period by using moving average models. Okay, which is we using the analysis when we using from that moving average k equal 1 until moving average k equal 9. And then we look about the exponential smoothing models. This one is we can refer from the table 5.1, okay? And then from this exponential smoothing model, we found that the lowest percentage of the error in the simple exponential smoothing with the alpha 0.2. Okay, this one is we can make the comparisons when we using the from the alpha 0.1 to alpha 0.9. And then the next model we using the Box-Jenkins models. Okay, this one we can refer from that tables. Okay, this one is a percentage of the error on the next field by using Box-Jenkins model. From that from this model we using from the PDQ. Okay, P from the 0 until P equal 9. Okay, so this one is when we make the analysis, we can make the comparison for the type of the forecasting models. The objective of the selecting the most appropriate forecasting model through the comparison between the MAP, MAE, MIC, and RMC by selecting the lowest percentage of errors. The values of the MAE, MIC, and RMC in the Box-Jenkins model is the lowest, and each of them are 0.08, 0.01, and 0.1 respectively. Box-Jenkins model is a method to predict the trend well. And then when we make the comparison of the type of the forecasting model, assessing the percentage of the error, we can look when the moving average 7s. Okay, we using the moving average 7s. Okay, and then the simple exponential smoothing alpha is 0.2, and then Arima 9.11. From here we can make the comparison from this analysis. And then from the three figures shown below, is found that the forecast figure 5.5 Box-Jenkins is the more appropriate and the accurate forecast to predict as shown in the line compared to others model. Box-Jenkins model can be selected and used as a quality control method that can predict and control the process for the production company. Okay, from here we can look when we using the moving average 7 models. Okay, you can look at about the actual value, forecast value, and fitted value. And then this one is when we using the simple exponential smoothing alpha 0.2. This one you can look the trend of the actual forecast and then the fitted values. And then the last one is when we using the Box-Jenkins 911 models. Okay, this one is we can make the look at the very good graph, which is the actual and the forecast is very close. Okay, and then the summary for this study is the next 10 weeks basically started from the week 18 to 27. And then the percentage of the error predicted from the week 18 0.28%, week 19 was 0.98%, and week 20 was 1.34%, and week 21 was 0.89%, until the week 27 was 0.78%. It indicated that the forecast has an average error prediction of the 9.93% and standard deviation of 0.31. And then we can look the percentage forecast error for the 10 weeks coming. Okay, so this one is we go to the last chapter. Okay, chapter number 6 is the application of the artificial neural to forecast product defect. This one is my research with the furniture manufacturer in Muar, Johor. This one is all the data and then the analysis for the bedroom set furniture. Okay, okay, first we look at about what the zero defects, because in this all the industry they aims to all the production is a zero defect, no any rejection and no any rework for this products. Okay, so and then the defect produced will be occur when they fail to reach the intended design and the improperly manufactured. So this one is the company is try avoid to reject or to redesign from that manufacturing process. For this study, we look at about what the problem is color defects. Color defect is one of the category of the product defects. And then how we can analyze, we using the artificial neural network. This one is a part of this the product, okay, and then we have the system sheet from this factory. Okay, what the problem statement here is based on the previous defect prediction research. This one is based on the Gianodin, and then from Umar, and then the Hong et al. And Bukos and Laplander 2009. Okay, and then we go to the artificial neural network (ANN) in this analysis. A set of the neuron connected in terms of the interconnection and composed in 2/3 layers in order to identify the input and output layer. And then from that, we can fit the best experiment data and widely apply in a different field to the conduct a forecast process. This one is how the step for this when we using the ANN. And then what the advantage when we using the ANN is a high accuracy rated result, the training with the less the formal statistical and complicated non-linear continuous function and predict in a large number of the variables. This one is what the advantage for this when we using the ANN. Overview of the defect prediction model here. Okay, because the first we look about what the defect prediction model based on the previous study. Okay, from the 5 previous study, we identified most of these the result is there is a very support to our research. Okay, for example, in the when we using the identify the based on the Zaudin, okay, because the Zaudin and Verma and Singh they found that they determine the cause of the problem and have to generate an appropriate solution model. This one is one of the strategy for analyze the defect prediction model. And then this one is our methodology to solve this problem. Okay, and then okay, from the based on the this from the Kabi and Sumi and Mustafa and Afran et al. A well-suited method to train the networks. Okay, this one we using the feed-forward neural network model, and then we using the Leavenworth market back propagation or LMBP, the algorithm, and the last one single hidden layer. Okay, this one is what the figures we found from this for this research. Okay, we using the input layer for the first hour, second hour until the 8 hours, and then we using the hidden layer on the ones, and then what the output layer we can find what the color defects unit. And then the process of developing an artificial neural network model. This one is the step for the process where we develop the ANN models. And then okay, this one is what the result, number of neutrons, number of neurons, and then what the mean squared error value when we using the 1,000 epochs, and then we using the 500 epochs, 5,000 epochs, sorry, and then 10,000 epochs. Okay, this one we analyze with the using the MATLAB application. And then this one is when we using the we can show the open windows of the networks. Okay, and then this one is what the result from this our analysis here. Okay, and then the last okay, and then we can look about we can show about the graph. Okay, when we compare the actual and then the forecasting value. These are very good. These are very near from the actual and then our forecasting value. Okay, what I can summarize for these models or the analysis is a model conducted in 11-bit market backpropagation or LMBP algorithm with a single hidden layer and trained with the 8 input neuron, 9 hidden unit in hidden layer, 1 output neuron, or with the 10,000 epochs. The neural network model provides a high accuracy of the prediction of the output values with the MAC. Okay, and the correlation coefficient is 0.9442. A well match between the actual situation and prediction shown in the comparative graph where the predictive numbers were obtained from the neural networks model with the appropriate properties after training the networks. Okay, before I close my session, I want to share my publication. This one is all my publication on topic forecasting since year 2003 in Proceeding and Journal Scopus Index. Okay, and then this one is a list of my research grant on topic forecasting since year 2001. And then this one is the last slide. Thank you very much to all the audience, and I close with the Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, that was the end of knowledge sharing sessions by the keynote speaker, Professor Dr. Muhammad Talib bin Bun. Before we conclude this event, we would like to congratulate the keynote speaker, Professor Dr. Muhammad Talib bin Bun, for his insightful shared knowledge. Thank you, Prof. Ladies and gentlemen, we would like to thank all invited guests and participants for joining us until this moment. On behalf of the organizers, we wish to make an apology for any shortcomings throughout this event. With that, wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.